This example from section 12.2 asks us to find r of t, the vector valued function given r of 0 equals I plus 2j. We call that an initial condition, and given the derivative r prime of t equals 3t squared j plus 6tk. So we want to be able to work backwards given r prime and an initial condition, find the antiderivative and find the constants that will give us the original vector valued function r of t. Let's set this up with an integration problem. We want to integrate r prime of t dt. That the integral of r prime of t dt is going to give us r of t. So the integral of what we have here is our r prime of t. Notice we're missing an I here, the I component. I'm going to go ahead and put 0I plus 3t squared j plus 6tk. And we're going to integrate each of the components. Now when we did definite integrals in the previous video, we added a vector of constants. Rather than add the vector of constants, I'm going to add a constant within each component and use the initial condition to find the value of those constants. So the antiderivative of 0, is a constant. We're going to label that C1. C1 is your first constant. The antiderivative of 3t squared is t cubed plus a constant. We're going to label that C2. That's your j component. And the antiderivative of 6t is 3t squared plus another constant. Let's label that C3k. Now, I do want to note that this could also be written as the t cubed j plus 3t squared k plus that vector of constants. So this is going to be your r of t. Your r of t, again, can be written like this or like this, either one. I like to write it out because you are going to be solving for each of the constants. We're going to use the initial condition that r of 0 is equal to I plus 2j. The vector valued function evaluated at t equals 0 is C1I plus, plug in a 0 for the t here, you get C2j, and plug in a 0 here for t and you get C3k. And that equals the initial condition r of 0 is I plus 2j. Now if this vector on the left is equal to the vector on the right, then the corresponding components must be equal. So the I component, C1I, needs to be equal to the initial condition I. And the C2j has to be equal to the j component of the initial condition. And then finally that last one, that C3k, needs to be equal to the k component on the initial condition. So we can determine the values of the constants. C1 would have to equal 1. Those two yellow shaded regions are the I components. C2 must equal 2. And then finally C3 would have to equal 0 in order for this r of t to have that initial condition. R of t is equal to, let's go back to C1I, that's going to be I, plus t cubed plus C2, t cubed, C2 is 2, that's your j component, And then the last component, the 3t squared plus c3, it's going to be 3t squared. Since c3 is 0, it's going to be your k. So our final answer can be written as shown here.